This is Dr. Santhi Sree. I am discussing about thermodynamics today. Thermodynamics. So, everyone knows what is a thermo means. It's related to heat, and dynamics is nothing but the bodies or the systems which are in motion. So, if you study the concept regarding the systems which are having heat and in motion, we can call them as the study is nothing but your thermodynamics. Why do we need to study thermodynamics first of all? So, when you come to a mechanical engineering course, in mechanical engineering, you have many streams like manufacturing technology, production technology, materials, design, etc. So, when you want to design something, yes, suppose I have designed a car. Okay, I have put some tires, mechanisms, etc. I used all the mechanisms required for that and I designed a car. But how do I know whatever the fuel I'm supplying to the car is flowing properly and it is supplying to the engine where it is required? So the flow of your fluid, the flow of your fuel, whatever you're supplying, is nothing but we can call it as the system in motion. So when it relates to heat, we call it as the study is nothing but your thermodynamics. So let's see what is the definition of thermodynamics. So when you want to say what is exact definition of the thermodynamics means, it's a branch of science. Of course, every course is a branch of science in engineering. As that way, the thermodynamics is a branch of science. The phenomena of energy and the related properties of matter, especially laws of transformation of heat into other forms of energy and also vice versa. So what does this mean? So the statement looks like a bit complicated, but what does it mean? What is inside of this statement? So this is nothing but the energy exchange. Energy means what are the energies we have? You have lot many energies in universe if you consider. You have a molecular energy. When molecules are colliding each other, you have collision energy. When they are rotating, you have rotational energy. When they are moving, you have with respect to velocity, it will come into kinetic energy. So energy may exist in different forms. You have potential energy. You have a work as an energy, heat as an energy. So among all these energies, when the energy is transforming heat in the form of heat into other forms of energy and energy in the form of heat, we call that as that science is nothing but your thermodynamics. So I can say thermodynamics is the science of energy transfer and its effect on the physical properties of the substance, and it's based upon the observation of common experience which have been formulated into thermodynamic laws. So I can say it's thermodynamics is an axiomatic science which deals with the relations involving among heat, work and properties of systems which are in equilibrium, and it describes the state and changes of the state of all the physical systems. So this is an axiomatic science. The word axiomatic refers to whatever you are talking about thermodynamics. We don't have any proofs. These are all axioms which we have taken as a conclusions based on a number of repetition of experiments. So it's an axiomatic science. So once you transfer energy, so whatever the energy you are transferring, finally what you have to achieve? Law of conservation of energy only. That is, energy neither be created nor be destroyed. It has to change from one form to other form. This change from one form to other form is nothing but your thermodynamics. And especially when you talk about the change of energy in the form of work to heat, heat to work is the what thermodynamics deals the kind of energy. Let's see where these thermodynamics are using. So whenever you are talking about some concept, first of all, what strikes in your mind? Why we have to study this? Where we are using? What is our application of this? So when you see the applications of thermodynamic laws or the principles, all fields of energy technology, like your power plants, whether it's steam power plant or nuclear power plant, your IC engines, that's the way the engines, the vehicles what you are using day to day life, like your two wheelers, four wheelers, or your gas turbines, your refrigerators, and your air conditioning systems, and your propulsion systems, gas dynamics, and compressors, and of course your chemical process plants, etc. So these are all the day to day applications what you are seeing. If you want your energy, if you want for light at your home, you need thermal power plant has to be there. If you have to convert your thermal energy into mechanical energy. So this energy transformation, this is where thermodynamics comes into the picture. Internal combustion engine, that is the combustible mixture will burn inside the cylinder and comes out as it releases some amount of the energy. Of course, that energy will be using it as mechanical energy for driving your vehicles. So there your thermodynamics comes into picture. So if you see day-to-day applications, many of the engineering technologies, many of the engineering fields, all appliances or components, so they all you have thermodynamics. So they are all based on thermodynamic laws and principles. Maybe you may not find exactly your air conditioning will use at home every day, but you may not think of that how it works. It simply will switch on with your remote and will use and will stop. But if you see the principle inside that, as a mechanical engineer, you will understand exactly what happening inside, how your air is becoming cooler when you require for cooling room, how it will become warm when you want it in a winter. So this is thermodynamics comes into the play. Whether you have to reduce the temperature or you have to increase the temperature, that is nothing but your temperature. You are changing temperatures. You are exchanging energy from hot to cold and cold to hot. So this is where your thermodynamics comes into the picture. So let's see some examples here. See the first one, what you do in the morning. Once you get up in the morning, you require a hot coffee, right? I have given you a coffee cup which is very hot. Can you able to drink? No, you require some temperature. How much you can able to drink? So that is what your energy is exchanging in the form of heat. So if you keep it there, sometime automatically it will reduce this temperature and it will be maybe environment temperature where you can drink, or maybe the temperature higher than environment where you require, where your mouth can withstand. So that is where the major, that is the hot coffee mug is the hot coffee is the major application of your thermodynamics. Of course, your heat exchangers, solar collectors. Nowadays, many industries are the energy, the heat we are collecting through solar only, because renewable energy sources we are using to reduce pollution also. Okay, hot water, your day-to-day usage of your geysers, hot waters, cold waters, your pumps. So every place we have thermodynamics if you deeply look into that. See, human beings. So why human beings are coming to thermodynamics book? Yes, we are human beings. See, now I am sitting here, I am feeling bit warmness. So how do I feel warmness? If I touch here, I feel like warmness. If I want to reduce my body temperature, I have to circulate some cold air over my surface. That is nothing but my warmness is becoming colder. My body is coming into a reduced temperature where how much I can withstand. So that is nothing but your thermodynamics, energy exchange, your coolers, etc. So these are all day-to-day applications. We don't feel, right? You feel like once you come out in the morning, you have a light breeze onto your body and you feel like, wow, nice weather. But what is that nice weather means? That means your body is feeling a nice wind breeze. That is, your human body temperature is exchanging heat with the whatever the air is coming from the wind. So there you have exchange of temperature. There you have exchange of energy. So that is where thermodynamics comes in play, the major role. So how do we see this thermodynamics? How do we suppose I'm saying yes, this is there, that is there, thermodynamics is playing in the role. So how do you see that? So for anything, for any system or for any what do you call a concept to understand, you should have some approach to understand that. If you want to go from one place to other place, you should have a proper route map to go. That means some proper approach you have to follow to understand that concept. So to understand thermodynamics, we have two different approaches, that is macroscopic approach and microscopic approach. So what is this macro and what is this micro? Of course, by this time you will be understanding the word macro means the word micro itself. Yes, exactly. The same English meaning only we are bringing into thermodynamics also. We are not changing the meaning of the word, but we are taking that meaning into our technical point of view. So in the macroscopic approach, if you see, a certain quantity of the matter is considered without the events occurring at the molecular level being taken into account. So what does it mean? What does events occurring at molecular level? What is quantity of matter is considered? Suppose I am in a room. So in this room, I have considered this place is my approach. This is the place where I have to think of it, where I have to focus. So this is macroscopic approach. So I'm looking into my camera, I'm looking into my TV. So these are macroscopic, as a quantity I'm looking into that. Now what about microscopic point? Microscopic means I want to see each and every component of that. For each and every point I have to check. Suppose you take a molecule, a gas. This is a gas having so many molecules in this. Definitely gas is having many molecules. So the macroscopic approach means, so in this molecules, in first three I have taken a set A, and here I have taken a set B, and these I have taken a set C. Okay, so in macroscopic approach, so this is my total region where I want to focus. In that region, the molecules are subdivided into some quantities, some volumes, or some portions. So whatever these molecules are having properties, generally we know from the chemistry background, as a chemistry learner, you will be knowing every gas molecule will have its properties like pressure, temperature, volume, etc. So if I want to say, see suppose now if I write A separately, how many I have taken? 3 molecules in A I have taken. So the molecule of PA, TA and VA, that means the average of all these 3 molecule values, molecular properties values, will give you the state of this point A. What is A? Okay, A is at a temperature of, B is at a temperature of, and similarly B and C. That is your macroscopic approach. When it comes to microscopic approach, micro, what does it mean? Micro means you have to see very part by part. You have to see point by point. So I can't take it into ABC. So if this is my system, I have to give A, B, C, D, E and so on. That means each and every molecule I have to consider. Now my PA, PB and so on. So each and every molecule property I have to take into account and I have to go for the analysis. So these are the 2 different approaches. Of course, in nature, most of the applications we do with macroscopic approach only. Okay, next. So this is the difference between macroscopic and microscopic. So let's see what is the major differences presented here. Microscopic means this approach considers that the system is made up of a very large number of discrete particles known as molecules, and of course these molecules have different velocities and energies. Whereas in macroscopic, of course they also you have molecules, but the behavior of individual molecules won't be considered. The study is the properties of particular mass of the substance. And in microscopic, the behavior of system is found by using statistical method, as the number of molecules are very large. You can't go as a randomly, you have to go statistically. And whereas in macroscopic, it just requires simple mathematical formulae. If you have, we have seen just dividing into 3 regions, A, B, C. So once you know the average of A, average of B, average of C, and A plus B plus C by 3, all the 3 molecules will give the total system pressure and temperatures. So the properties like velocity, momentum, impulse, etc., which describes the molecule, cannot be easily measured by instruments here, because each and every particle, right, it's very difficult to calculate the properties majorly like its impulse, its energy, its momentum and all. Whereas the properties like temperature and pressure are required to describe the system, which can be easily measured, because we know you have many methods, many devices to measure the properties like temperature and pressure. Okay, and the last but not the least is large number of variables is needed to describe such a system, so the approach is very much complicated. If only a few properties are needed to describe such a system. We are not saying we don't do microscopic approach. Of course, you do microscopic level. You will be studying the structures. Nowadays, we are dealing with virus. This virus has to be studied microscopic level only. You can't go by macroscopic. But our thermodynamic systems, our thermodynamic units, we don't require microscopic approach much. You can go easily macroscopic approach. So, to study any concept, it's a thermodynamics or it's a manufacturing technology, it's a production engineering, to study into that, you should be aware of some terminology for that. To describe something, you need some terminology for that. So, that is nothing but what are the basic definitions, basic terminology we'll be using in thermodynamics subject, in the concept of thermodynamics. So, let's see the first and the most important one is what is a thermodynamic system. A thermodynamic system is defined as a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem. So the definition is very clear. It's a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem. So now I have a system here. Suppose my laptop I'm considering as an example. So if you take your laptop, you will be focusing on the video where you are watching only. So that is your focus, that is your area where you are concentrating much. Only that portion, whether you want to maximize or minimize or you want to, increase the volume, decrease the volume, you will do for that only. Some other thing is running behind, you won't consider about that. You won't deal about that. So where you are focusing. So in the total room, my attention is now here. This slide, this place is my attention where I have to focus and I have to deliver my lecture. So this is the reason where I have to focus. This is the reason where I have to analyze. Is this is good? Is this is safe? Is this is neat? I can sit. Is the comfortable chair is there? So this is the place I have to focus much so that I can do my analysis and I can concentrate much to analyze the problem. So that is what we call it as a thermodynamic system. So this is in a space. So you take your college, you have a big, so many acres of college. But where you will go and sit, your attention is your classroom. Your focus is your classroom where you have to go and sit. So that is what you are going to check. You will be going to write a competitive exam, suppose. Right? When you go to write a competitive exam for a new college, will you see all the college or will you ask somebody where is this room so that I can write the exam? So you have to focus, your attention is your room where you have to write the exam to analyze the problem. So that is the place you have to write your exam. So that is your attention you have to focus. Similarly, in a system, if I have, see the figure, you can see the figure at the down. See, that is a total space you have. So in that space, so the dotted areas, whatever is there, this is my system, what I have considered. So this is only the place. I am not talking about this part and the remaining part wherever empty space is there. Only the dotted region. This is my system where I am focusing so that I can concentrate, I can apply my laws, I can apply my methodology, I can get the results, I can interpret the results, I can validate my results. Completely I can do the experiment over there. So this is my system where my attention is concentrated such a way to analyze any problem, to get any result for that problem. So then what about in the total space, if I consider only a small part, what about the remaining one? That is nothing but your surroundings. Whatever external to the system is called surroundings of the environment. Okay, clearly I can give you this. Before that we'll go to the example, we'll see another one is boundary. What is this boundary? You need something to separate your system to surroundings. So that separation, what is there, what is the line or what is the boundary is nothing but your boundary. That is the system which is separated from the surroundings by system boundary. And the system and its surroundings together comprise a universe. You have a flat. You are living in a flat. It's a 3-bedroom flat, suppose. So that is total is your space. In the 3-bedroom flat, you have a room separately. So that room is your system and the remaining part of your room is your surroundings in your house. So your flat is now universe for you, and your room is a system for you, and the remaining all the part other than your room is your surroundings. So you will be having a door, right? From which your room is separated from the other part of your flat. That is nothing but your boundary. I hope you understood this clearly. A system, surroundings, boundary, and universe. So these are the most important definitions so that we can focus, we can analyze. So generally in thermodynamics, we talk with thermodynamic systems, surroundings. These are the terminology which keeps on running behind us to discuss anything about your thermodynamics concepts. So boundary. So what type of boundary you will have? As we know, the line separating the system and surroundings is known as boundary. So is the boundary is fixed? Not required. Is the boundary is movable? Not required. It is adiabatic. So as per some references, so with respect to volume and with respect to heat transfer, these boundaries can be classified. So with respect to volume, what do you mean by with respect to volume? It's a fixed one or movable one. And with respect to heat transfer, your boundary may be adiabatic boundary or diathermic wall or diathermic boundary. That means diathermic wall is nothing but which allows heat to be transferred. Adiabatic wall is one which does not allow any amount of the heat to your system. That means your boundary is fixed. It won't allow any changes. So with respect to volume, we simply say it is a fixed boundary and a movable boundary. But with respect to heat transfer, we say it is an adiabatic boundary and diathermic boundary. So diathermic boundary is the one which allows amount of heat transfer, and adiabatic boundary is one which doesn't allow any amount of heat transfer. The other definition which is important one is state of system. So what is the state? So this is a condition, a macroscopic condition of a thermodynamic system as described by its particular thermodynamic parameters. So if I want to say what is the state of this pen what I am using. So this I will say with parameters. Yes, this is my system now. So for this system I am explaining as a macroscopic point of view I am saying this. I will explain this is in black color some parameters. This is in black color, this has one eraser, this has one point. So these are the parameters which describes the condition of this system. It is movable or it is fixed. What might be the condition? So a state is a macroscopic condition of a thermodynamic system as described by its particular thermodynamic parameters. The parameters may be pressure or temperature or density or its composition, anything. Okay, so these are the basic parameters anything will describe like a system which you have to talk about. And these systems are classified into three categories: open system, closed system, isolated system. So whenever you are talking about something, definitely you need to classify that. Otherwise we can't take as a whole and we can't take as a summary, you can't do any analysis. So thermodynamic systems are broadly classified into open systems, closed system and isolated system. So what is this closed system? Closed. The closed system means it's having a fixed mass. As we know, thermodynamics itself is transfer of energy, right? Energy means from where to where it has to transfer? From system to surroundings. So when this transfer of energy or when there is no transfer of mass across the system boundary, we call that system as closed system. You may have energy transfer from surrounding to system or from system to surroundings, but the mass is fixed. If I say it is 1 liter container, it is 1 liter container only. I am not changing any mass. I am just changing the energy. So that is, there is no mass transfer across the system boundary. So that is called a closed system. A certain quantity of fluid in a cylinder is bonded by a piston constitutes a closed system. A best example which we consider a piston cylinder device for your IC engines also. Then what is the other one? Open system. So this is the one in which the matter, that is the mass, crosses the boundary and also energy also transfers. That means you have both mass and energy can cross the boundary. What do you mean by crossing boundary? Can exchange mass and energies from system to surroundings and also from surroundings to system. The best example is what we see day-to-day life is an air compressor in which air enters at low pressure and leaves at high pressure. So the energy is also transfers across the system. The other one is your isolated system. Isolated. Nowadays we are hearing this word very frequently. Isolated, that means no interaction only. You don't have any interaction. The system does not have any interaction with surroundings. There is no mass transfer, there is no energy transfer. Whatever the mass, whatever the energy, that is fixed only. So that is what isolated system means. So let's see diagrammatically what is a closed system, open system and isolated system. See, if you observe this closed system, this is the system what I have considered. So I have a boundary and I have surroundings and this is my system. So if you see a closed system, no mass transfer, energy is entering and energy is also leaving here. The same system, other one. So here mass is entering and also mass is leaving. Similarly, energy entering, energy leaving. So this is an open system. So I can say closed system, energy, mass, you have energy transfer, you don't have mass transfer. Whereas for open system, you have energy transfer and also mass transfer. But for an isolated system, you don't have both. So if you observe, this is insulated. Surroundings are insulated. There is no interaction from system to surroundings. That is what your isolated system means. So most of the applications are open systems only. Okay. If you observe your power plant, especially. So power plant, what are the components will be having? So power plant, you will be having a boiler and a turbine and a condenser in general, and this is a pump. So you have an interaction between boiler to turbine, turbine to condenser, condenser to pump and pump to, I can show this by using arrow marks, boiler. So this is a basic power plant which constitutes a boiler, turbine, condenser and pump. A thermal power plant suppose. So you will be supplying some amount of heat to the boiler. So boiler, the water will get boiled and it will comes out with high temperature steam with high pressure, enters to turbine. Turbine is an expansion device. So this is connected to your generator which generates your electricity, converts work in the form of electric work, and then this amount of the heat will be entering into the condenser. What is the purpose of condenser? Condenser will condenses, that is the steam will be condensed into liquid droplets of water. So this liquid droplets of water will send to boiler through a pump with supplying of some amount of the work. So if you see this as a whole unit, this is a closed system. But if you see an individual devices, they are all open system. See the boiler, both energy and mass transfers are there. Turbine is also there. So if you see as individual components like boiler, turbine, condenser, pump, these are all individually, they are all open system. But when you keep all in a drawing a boundary, this is my external, that is surroundings, that is a closed system. So the best example is this. So that's the reason we say individual, all the components, a boiler, an air compressor, a turbine, condenser, these are all open system in nature. But as a whole, A power plant is a closed system. The next definition is property. So what is this property? So we are talking about system, parameters and all. So every system has certain characteristics by which its physical condition may be described, like its volume, temperature, pressure, etc. These characteristics are nothing but properties of the system. Right? If I say, I have a cup of coffee in my hand. So if somebody, if they won't tell you it's hot, it's at a temperature of 80 degrees, generally we won't use coffee at 80 degrees. We say simply it's hot. If you sip, it will be effective for you. That means you have to describe that, whether it's hot or it's cold. Of course, the hotness or coldness is described with the parameter is called the property, that is temperature. If I give you a 5 kg rice bag to a 2-year-old boy, can he able to hold? No. We'll say, no, don't hold it because it's very heavy. It's a 5 kgs. That is, its volume is high. Its mass is high. So, to describe any system, you need some characteristics. You need some properties. So, that is nothing but, the characteristics are nothing but what we call it as the properties of that particular system. And we have, to describe any thermodynamic system, you have an intensive property and also an extensive property. So what is an intensive property and what is an extensive property? That comes to the topic now. Intensive. So if you are pronouncing properly, you can give the definition of that. Intensive. So these are the properties which have same value for any part of the system, or these are the properties which are independent of mass of the system. They are not depending upon the mass. If I want to describe my room is very hot, that means I can give it only temperature. I'll see if I am 80 kg also I feel hot, if 30 kg person also feels that the room is hot. So that is an intensive property. That is, the measurement of hotness is nothing but your temperature. So temperature is an intensive property which is an independent of mass. So intensive, independent of mass. The other one is extensive property. So these are the properties which are depending upon the mass of the system, and they don't have and they don't maintain the same value for any path or any point of the system, like your mass, your enthalpy, your energy, your volume, etc. Yes or no? If I want to say about my energy, in the morning I am full energy, in the afternoon my energy goes down, by evening it will go reduce. It is not the same value throughout the day. But if I am working in the same room from morning to evening, I can say I am working at ambient temperature, or I am working at 20 degrees centigrade, my room temperature is. Yes, sir. So that is what extensive property. Energy is an extensive property. So intensive properties, extensive properties. Independent of the mass and dependent on the mass. You have to note down one more is an specific property. That is, a property per unit mass is specific property. You might be studied in your physics when you are in school, specific volume. What do you mean by specific volume? Volume per unit mass is called specific volume. The ratio of, so till now we don't know what is extensive and what is intensive. When you are in the school, you might be knowing volume per mass is specific volume. Now, with thermodynamics, some knowledge of concepts of thermodynamics, some definitions of thermodynamics will define like the ratio of extensive property of the system to the mass of the system gives the specific of the property, and that is again an intensive property. Because that is independent, it became independent to the mass. We consider with respect to mass, per unit mass, per mass. So that is independent of the mass. So that is again, so the ratio of extensive property with respect to the mass of the system gives you an intensive property, and those properties we call them as specific properties. In thermodynamics, remember, we'll generally use specific enthalpy, specific energy, specific heat. Of course, this is the word very much used to you by when you were in intermediate or in 10th class. Specific energy, specific heat. So that is an intensive property. Okay. Of course, now I have some properties which describes the system and which will be changing or which won't be changing, something like that. Then, if all the change of states of the system are plotted, suppose I have a system on some xy coordinates. So here one property I described, here one more, here one more, here one more, like this. So if I draw by joining all these lines, I'll call that as a path. That means here one A and this is B, this is C and D. So each A, B, C, D we call them as change of states. So now I'm here, the person is here now. He has to reach here. He has to reach to this point. So he has to cross A, B, C, all these points. You are at home and you have to reach your college. You won't come like this, right? You have to start from your home and you have to reach your college, means in between you have to cross many paths, many states, many signals, many lines. Yes, sir. Simply like that, if you close your eyes, jump, and you won't come and appear in the college. So if you plot all this, if you line all the way, whatever you come across, that is nothing but your path. That means if all the change of states of that particular system are plotted, the line joining that change of states of the system is known as path. Okay, so this is the path what I follow with all the, this is all change of states on xy coordinates, suppose. And this is A and B, suppose. If I come back from B to A in different path, that is called a cycle, thermodynamic cycle. So this is defined as the series of state of changes such that the initial state is identical with the final state. Some good students will be there in class. They'll start at home, come to college, they'll finish college, they'll go home. Their initial point is home, their final point is also home only. In between they moved through college. So that is called a cycle. See here, clearly explained. It's a property A, property B. Two properties are there which describes the nature of the system. I have a state point 1, state point 2. So if I join all the change of states between 1 and 2 like this, so that is called a path and it's a process path. Let's come with, now I am changing these properties as pressure and volume. A bit advance of this figure. The pressure from 1 to 2. So this is my P1, this is my P2. So pressure is changed from P1 to P2 and volume is changed from V1 to V2. You can observe this arrow mark. So 1 to 2 is the path what it has been followed. So this is my initial state and this is my final state. When I come back 1 to 2 and if I come back from 2 to 1, that is called, now this is, I can say 1 to 1 is a cycle. It is not required to have only one path. You may have more number of paths, but the final destination should be, the final state of the system should be identical to initial state. You have to understand the word identical. We are not saying equal because properties, there is a minimum error must be there. You might be having a minimum error, but you may have many paths. But the final state must be identical to initial state. Then we call it as a cyclic process. It may follow any number of processes in a device, but your final state should be identical to initial state. Let's take this one. I followed a path 1 to 2, suppose A, 2 to 3 in B, and 3 to 1 is again C. See, if you see, 1 to 2 is one path or one process, 2 to 3 is another process, 3 to 1 is other one. So now I reached to my initial where I started, that is point 1. So this I'll call thermodynamic cycle. A process, path, change of state, state point, change of state, path, process, and a cyclic process. These are all relates to again the system only, where your focus is made, where your attention, you are concentrating for analysis of your problem. So that is the basic definitions of thermodynamics. And these are the terminology it will be running, you will be carrying throughout your thermal subjects, throughout your thermal, like your thermodynamics, thermal engineering, whatever. A system, a process, cyclic process, system is undergoing, etc., etc. Okay? Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.